Hi guys, so today I'm going to go through some of the Edulastic review for trigonometry review. This first one comes from the multiple choice one. This is the one that it seemed like gave people the most difficulty. So first thing, I think we just forgot about what we would do with this. So you know how we do, where does my trig graph of one period start and where does it end? Okay, so we take the inside piece and we set that equal to, I was saying 2 and then I wrote a 2. So we set that equal to where it starts normally, which is 0, and we're going to take the inside piece and set that equal to where my cosine curve normally ends, which is after one period, it normally ends at 2 pi, and we're going to solve from there. So this is asking what is the phase shift. So it starts, I add pi, and then I'm going to divide by 3. So it's going to start at x equals pi over 3. So instead of starting at 0, it starts at pi over 3. That means it went to the right pi over 3. Okay. All right, so we're going to start out with the next set. All right, and this one is from the pre-calc trig review. So first thing, we've got sine is equal to 8 over 17. This is the first question of the whole entire thing. So I've got sine is equal to positive 8 over 17. And cosine is less than 0, so that means the x value is negative. So if we were going to draw our chart, my x values are negative in the second and third quadrant, and my y value, since sine is y, is positive in the second quadrant. So we are going to be dealing with our triangle in the second quadrant. And that's what I get from the first two pieces of information. So we can now answer this question. All right, what is the value of cosine of theta? And then what's the value of tangent of theta? Well, once we have the triangle drawn, I can say sine is opposite over hypotenuse. And then we have to find this side. But remember, it's to the left, so this is going to be negative, and then whatever number that comes from when you do the Pythagorean, when you do Pythag, a squared plus b squared equals c squared. Okay, so it's just going to be a negative value because of it being in the second quadrant. All right, onward. And then cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right. So next one, this one is a little bit tricky. So I'm going to start out with the amplitude. So that is, it goes up 1 and down to 1. So the amplitude is 1. Now D is the vertical shift and Y equals D is the midline. So right through the middle, right there, it doesn't look like it gets shifted up or down at all. So therefore, D is 0. Okay? And then we have the period of the function. So the period is one full duration of sine. So that goes from 0 to 2 pi is one full period. So the full period is 2 pi, but it looks like it's telling me in degrees. So my full period is 1. Okay? All right, because 360 divided by b is your period, so 2 pi, it would be 360 divided by 1 would give me 360, which is equivalent to 2 pi. All right. Next one, we are choosing all the values of theta, all of them, so it's not just one of them, it's all of them, that will make sine of theta equal to negative 1/2. All right, so we're talking about a y value that's negative. So we're talking about this quadrant and this quadrant. Okay, so pi over 4 is in the first quadrant. 3 pi over 2, the y value at 3 pi over 2 is not -1/2. All right, so then I go from my remaining ones. This is on the unit circle and this is on the unit circle, so I can analyze that. But this is bigger than 2 pi. So I want to find what is that coterminal to, so I have to subtract 2 pi from it to see what it's coterminal with, to see if that lands in the third or fourth quadrant and then would give me a y value of -1/2. Same with this one, I would have to subtract 2 pi to find the coterminal angle to then determine if it is, in fact, a y value of -1/2. All right. Okay, so we've got our graph. So I'm going to just change color and I'm going to go through the middle part of my graph. Let's see if I can hit these. Ooh, wow. I hit both of those dots. That's a first. I'm getting used to drawing with this on the computer, so I'm pretty impressed that I hit both of them. Don't mind me. All right. So my amplitude, it starts at 100 and goes up to, it looks like 150. And it starts at 100 and it goes down to the lowest point is at 50. So it looks like it goes up 50 and down 50. So my amplitude is going to be 50. My graph, this middle line right here, this green one, is shifted from 0 up 100. So that's my vertical shift. So I'm looking for plus 100 as the second part. So I can get rid of those. Okay? And then I have to determine, well, what graph does it look like? Okay, does it look like a cosine graph or does it look like a sine graph? Okay, so that's what you guys are going to be looking at. All right, this is the toughest one. This one, I don't even know if we had one person that got this right in the class. All right, so this is the last one on here. This was the hardest one. So we've got terminal side is going to be, I'm going to just change colors back to the blue. I like writing on here in the blue. So that is in quadrant 1. So I'm going to go ahead and do that. So it's saying my x value is 7/9. My y value is 13/15. Okay, so this is kind of messy. And this is angle A. So we want to find sine of A and cosine of A. So for both sine and cosine, I need the hypotenuse. So I'm going to need to do 7/9 squared plus 13/15 squared equals c squared. And I'm going to have to find what c squared is. And then sine would just be opposite over whatever my hypotenuse is. Okay, cosine likewise would be my adjacent over whatever my hypotenuse is. Okay, and then we would just do 2 times that number and 3 times that number. Okay, so that one becomes a little bit tricky just because you're dealing with fractions and you are going to be winding up doing, you know, a fraction divided by a fraction for sine and for cosine. All right. And that's it for those 2 sets.